Hello everyone! GraDriGO can be used as a VST or as a procedural audio generator in your video game. It comes with the basic pack of sounds to get you started, but the real fun begins when you code your own. And so, today I'd like to talk about the programming language which is at the core of GraDriGO. GraDriGO stands for Grammar-Driven Game Audio Output, and it's a programming language for audio. A number of audio programming languages were created over the years. In the 1980s, it was Max and C-Sound. In the 1990s, it was SuperCollider and Pure Data, and recently Xilang and Orca. Most of these systems are virtual module synthesizers or very intricate sequencers and timers. GraDriGO is different. The audio output is generated sample by expanding the rules of the grammars presented to the engine. Let's see how such a grammar would look like for a digital alarm clock sound like this one. Every second, there are 4 square wave beeps at 4000 Hz, followed by half a second of pause. And we have 20 groups of such beeps. Our audio interface output is at 48 kHz, and to make a tone at 4 kHz, our square wave will have the period of 12 samples, 6 low and 6 high. First, we need the 6 low samples and then 6 high samples, and this defines our waveform. And we need 250 copies of our waveform so that we have generated 3000 samples of audio. And then we need another 3000 samples of silence. And then we can copy this thing 4 times over, and we add a longer pause, which is half a second long. And now we have generated 1 second of audio. And now we simply copy this thing 20 times so that we have our alarm clock signal. How to write this thing as a grammar in GraDriGO? So first, let's define the minimum part of the waveform, and then the maximum part of the waveform. And then we said that the waveform is essentially a concatenation of the minimum and the maximum. And then the tone is something which lasts 3000 samples and is essentially a loop of the waveform. I'm just going to recompile and see if the waveform really sounds the way how it should sound like. So that's our tone. And then we have a short pause, which is something which lasts 3000 samples and contains only silence. And we have our beep, which is essentially our tone and a short pause. And then we have our long pause, which is going to be something which is going to be a 24,000 samples of silence. And then we have our beep, 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 which is the beep, 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 and a long pause. I recompile and play it. And then finally the alarm is essentially this thing repeated over and over, and we actually can say that it's going to be 20 seconds long. In this example, I defined a number of tones which differ in their pitch based on the period of their waveform. Let me compile them and let me play them for you. And of course, we can concatenate these to make something, let's say, more meaningful. Since all these boxes were named just using a single character, I could use this syntactic shorthand here. And instead of typing things like this, I could type this. And it makes it for somehow more convenient syntax. To specify the volume level, you can use the command vol, V-O-L, volume. And let's say that we will start at the 0.5, which is the 50% amplitude. And we want to play the first part of the phrase at this volume, and then we want to go to 1.0, the full volume. And then let's get back to 0.5 like this. And let's just shorten it up a bit. Now we can hear that this part has been accentuated, and these parts were of the lower volume. You can also specify a fade out. So let me just bring this back, and we can say that we just want to do the fade out, which is going to last, let's say, 2 seconds. And so whatever this box was producing, the volume was gradually changed from 1.0 to 0.0, and it took 2 seconds for this change to happen entirely. Fade out was going from the current volume level down to 0. Fade in works in a similar fashion. So when I do fade in, tilde2, I'm actually starting a fade in, which is going to last 2 seconds and will go from the current volume level up to 1. It's important to understand that fade in and fade out, they can coexist with the volume statement, but you have to be careful, because if I do this, I essentially disable the fade in, because I've already been at the 1.0. If I need to specify volume steps inside the fade out, I can do that, but I need to enclose the part that I want to modulate by those volume steps in these curly brackets, which creates a subsequence. And what happens in that subsequence stays in that subsequence. So let's say that I'm going to start with something soft, and then I will go for the full volume. And then I will go for something soft again. And yeah, and when I play the whole thing, I can hear that the sound started soft, then it went loud, and then it went soft again. But at the same time, the fade out was modulating the entire thing from 1 to 0. GraDriGO is based on the sample concatenation, and so there is no concept of timeline. If you want something to last a specific amount of time, produce as many samples as needed. So, for example, at 48 kilohertz, 1 second will last exactly 48,000 samples. So if I say 1 second is going to be 48,000 samples of a loop of, let's say, this square wave-ish. Yeah, so now this sound will last 48,000 samples and then it will stop. The same thing I could have done by typing tilde1, and tilde is a converter which takes the number and multiplies it by the current sampling rate, which is 48,000 hertz, but it really depends on the settings of your audio interface. So this thing will also end up lasting 1 second. I can do, of course, those are floats, so I can really do short snippets or long periods, as you could have seen before with my 20 seconds alarm clock. There is also a possibility to specify music quantities. If I type exclamation mark and then the number, it means this many quarter notes. So this would be 1 quarter note at the 120 BPM, which is default. This is default. If I go and say 100, then this quarter note is going to be longer, of course. And again, also this thing is also this value is also a float. So if I do a quarter note, I type 0.5. If I 1/16th note, I type 0.25, and so on and so forth. So let's try 4/16th notes with fade out. So I'm gonna type something which is going to last 1 quarter note, and it's going to be a loop of something which lasts 1/16th note, and inside I'm gonna have my fade out, which is going to last exactly the same amount of time, and it's going to be a loop of some waveform. The chiptunes utilize a lot of square waves, sawtooths, and noises to replace the cumbersome concatenation of waveforms manually typed in. GraDriGO has several built-in waveform generators, so this and this would be the same thing. Each time GraDriGO encounters this SQR, it produces exactly one sample, and it would be either the minimum or the maximum, depending on the internal counter. And this is the overall period length in samples. And we don't have to type 16 SQRs like that. We just type 1. And so what it does is just produces one SQR output, and then loop back, and then another one, and then loop back, and then another one. So it would just eventually produce 8 low samples and then 8 high samples, and so on and so forth. There are 4 built-in generators at the moment. There is Square, you've heard that one. There is Sawtooth, and then 2 noise generators inspired by Atari 800XL. So this is 5-bit and this is 17-bit. You can hear that the 5-bit is essentially somewhat regular, and so that's why it used to be. It was used for car engine sounds in arcade games, whereas the 17-bit noise is essentially square wave modulated by white noise. So it has this really random characteristic, but it still does have some kind of a pitch. If you want to do full white noise, you just do this. So essentially 5 generators. So square, sawtooth, 5-bit, 17-bit, and a white noise. There is no explicit timeline in GraDriGO, and there is no explicit tuning mechanism either. So in order to produce a tone, let's say A4, we need to calculate how many samples in a period we need to have. So let's produce a half a second of that. So, and now what do we put in here? Well, some number of samples. And how many samples there would be? Well, so our sampling rate is 48 kilohertz, and we want to produce 440 hertz, and closest integer to it is 109, so we just put in 109, and this is RA4. This is how pitch was specified on old computers such as Atari 800XL. Since the period is specified as integers, the tuning was really not precise, and that's something which is super characteristic of the chiptunes of that era. To save you from using the calculator anytime you need to specify a note, you can use a hash converter, which converts the number just behind it into the number of samples in order to make the period you want. So to play A4, just write hash and 69, because that's the MIDI number of A4. If you do, let's say, hash 60, you would end up playing C4. If I do, let's say, 48, I go 1 octave lower. If I go 36, go still 1 octave lower, one octave lower, and so on and so forth. This is useful when you want to specify notes as some sort of numeric parameters. But sometimes when you are typing melodies, it's better to use these built-in constants. When I type A4, it means exactly 69. If I do G4, it means 67. If I do F4, it means 65. If I do C4, it means 60, and so on and so forth. So there's also all notes have these constants built in. You can even use flats. So this would be E flat 4. This would be, let's say, C sharp 4. I know that here that this hash and this sharp kind of look weird, but that's what it is. GraDriGO can play multiple boxes at the same time, of course. There are two types of polyphony. First is voice-based, as in you can trigger any box as a voice, and this voice will exist for as long as it has samples to produce, possibly infinitely, and you can start any amount of voices as long as you have the CPU for it. The second possibility is to have parallel sequences in a single box. Let's make the same chord, but this time around using only a single box. It's gonna last 1 second, and it's going to consist of 3 parallel sequences. So one is going to be the loop of square wave at C4, let's say, and we're gonna have another sequence which is going to do E4, and another sequence which is going to do G4. It's the point of GraDriGO to be able to play a box from inside another box. So if we type something like this, and if we compile it and play, we would expect that by playing X we are actually playing this chord. But when we play it, we don't hear this nice chord. So what gives? So the problem is that when we instantiate a box, each of its sequences receives a single instance of the counter for its waveform generator. And this instance is used by any waveform generators inside that sequence or in any of its subsequences. And here, in case of instantiating the chord directly, we essentially run 3 sequences in parallel. But in this case, we instantiate only one sequence, and these 3 sequences become subsequences of this sequence, and therefore they are using this sequence's instance of the counter. So to counteract that, you need to specify that each of these sequences is supposed to use its own counter. And now it's going to work. Without it, we will just go back to the ugly sound here. GraDriGO would not be a proper programming language if it didn't have variables and some basic mathematical expressions. There are 3 types of variables in GraDriGO. One is global. You can define global variables like this. Let's say this one is going to be C4. The T is going to be assigned C4, and then it could be used like this. And of course, if we have another box, let's say box A, which is going to modify this variable to be, let's say, D4, and then we have another box which is going to be box B, and it's just going to do, let's say, B is E4, then by triggering one of them, we will change the value. Then there are voice variables, which would be used whenever you pass a value as a parameter. It looks like this. Let's say that we have a tone, and it is going to receive the parameter P, which is going to represent the pitch, and the tone is going to last a quarter second, and it's just going to do the square wave of this this value. So if I do, let's say, 60, it's just going to play whatever note I want. And then I can make a little sequence here, which is going to play tone, let's say C4, and then it's going to play D4 and E4. So this sequence is triggering this box 3 times with a different parameter of P every single time. And please note how I use the hash converter here. It works on variables as well. So this is actually the MIDI note number. So I still need to convert it to the period. Otherwise we wouldn't get, otherwise I would get something like this. Because now I'm essentially passing these values as durations of periods and not as MIDI numbers. So I need to convert it from MIDI numbers to the periods. And to save some typing, there is a shorthand syntax available here that I only need to write down the name of the box once if I want to use multiple instances in a sequence like this. And there is the following feature in the standalone editor when you click enter note names using MIDI, and when you have your MIDI keyboard attached, you can just press keys and it will enter the respective names automatically so that you don't have to type those either. The boxes can receive multiple parameters. Let's extend the tone to also receive the parameter A, and the parameter A is going to be the volume. And now we need to, when we are making the sequence, we also need to specify the volume for each note. So let's start with the really soft C4, and then slightly louder D4 and very loud E4. And the shorthand is still in place. It's slightly more complicated now because we have two parameters. We can do like this. We can say tone 0.1 C4, and then when I say D4 and E4, it is going to repeat this parameter and this box for this value and this value as well. And then I can change the volume from this point on by just typing it and adding the colon afterwards. So now we will have 3 notes playing softly and 2 notes playing louder. And lastly, there are sequence variables. Whenever you mention a variable anywhere inside a sequence for the first time, it will be visible only from that point on until the end of that sequence. And you can do like a pitch slides and volume slides and all these kinds of things. GraDriGO has the basic operations: addition, subtraction, multiplication, and division. It also has a floating point modulo and floor. And it also has syn2pi, which is the sine of t multiplied by 2pi. It's useful because most of the times you are interested in frequencies and not in angular velocities. And this is an example of a box that calculates its own signal and sends it out sample by sample using this out statement here. It's a little sine wave generator. The P, the %P is the phase, and Y is the actual amplitude that we are sending out for each sample. GraDriGO supports MIDI input. Several things to mention. There is a variable n, which represents the note number of the key which has been pressed, and v, which is the velocity. So let's make a simple key. It's a keyboard, which is going to be a loop. The volume is going to be %v, and we're going to play a square wave at the period corresponding to the MIDI number. There's one thing which is very important, and that is that we need to map the MIDI keys to our boxes. So I'm just going to type 0 to 127. So this is essentially, so the first parameter is the starting number, starting note. This is the ending note. This is the name of the box I want to connect. Now when I recompile, you can see that the keyboard went green, and now I can play. You may have noticed that I didn't put any duration specification here, and still the box didn't last forever. It was delimited. The trick here is that the voices, when they are being triggered using MIDI keys, they are also released by the MIDI keys. And there is an implicit release label which is placed just before the end of the sequence, and you can actually make it explicit by typing it, and then whatever happens after here, after the release label, gets interpreted after the key is released. So if I go crazy and do like, I don't know, say duration 0.1, and that's going to be just a loop of, let's say, noise 510. It's going to do this little glitch at the end of the box. Right? There is no reason why we shouldn't replace it with something more sensible. For example, square wave, or better yet, the same note, and the best, the fade out. So now we have a super simple way how to do a release phase. So we have a very simple release envelope. Now you know enough that you should be able to understand what's going on in most of these presets, and you can start making your own collection of sounds and noises. Once you're done, it's really easy to link these sounds to your game in Unity or start using them as a music instrument in your DAW. I will cover this in my next videos, so please subscribe, stay tuned, and thanks much for watching. You can support this project by joining my Patreon, and thank you very much. Until next time.